So let's have a look at calculus. And in this specific case, when we are dealing with cubic equation, what do we mean by cubic equation when we have x to the power of 3? So we have function f, and here we are given that equation of function f, and like I'm saying, this cubic equation, we can see x to the power of 3, 2, and x, and a number. So what do we need to do? We need to find what? Derivative. And then hence, meaning what? With that knowledge of having derivative, we have to find, so second part, the slope of the tangent to fx at the point. What does that mean, that second part? So I have this function, and there is a point, I don't know, I'm making that up where it is. So let's say here, there is a point that has coordinates 2 and -4. And if I draw a tangent, a line that will be touching our curve at only that specific point, that line here will have a slope. And we have to find that slope. Okay, first, let's create derivative. So how do we derive? Each element we derive separate. So those are the elements. Now, when it comes to x to the power of 3 and x to the power of 2, in our table, there is a formula that is saying when you have x to power, what you do in order to create derivative, you take that power in front of your x and then that power -1. So applying that here, if I have x to the power of 3, that means that power will go in front, 3, then I have x, and then that power, which is 3, -1. So that means 3x to the power of 2. Now, let's do the same for the next one, -3x to the power of 2. The problem we are having here, or the slight problem we are having here, is that what do I do with this 3? Well, the number crosses over. Nothing happened, nothing changed. So -3. The rest, again, follows the same pattern. So the power goes in front. My power is 2, so it will be 2, followed by x. And then the power I have -1, my power is 2, so 2 -1. So that means -3 multiplied by 2, that will be -6x, and 2 -1 will be 1, or we can live without power. Now, what happens when I have a number and then x that has no power? Derivative is the number that stands beside x. So in this case, 4. Now, what happens with the number that doesn't have x beside it? In the process of creating derivative, that becomes 0. So really, we are applying our formula only to the elements that have the power of 3 or 2. Okay, so therefore, let's put that all together to write our derivative. So our derivative will be, the first element was 3x to the power of 2, the second element -6x, and the third element +4. We know we can ignore 0 because 0 is what? Nothing. Okay, so we did the first part, we found the derivative. And now they are saying hence, meaning with that knowledge of having the derivative, that will help us to find that slope of that line. Now, we need a little piece of knowledge here. And that piece of knowledge is that the value of derivative at a specific point will be the same as the value of the slope at that point. So what do we mean again? The value of this slope of the tangent at that point, let's say that value is 5. The same way will be the value of derivative at that point. What is the value of derivative, or what is the value of the function? Is the value of y. That's where I have y. Don't forget, it exists in coordinate geometry. It's between the x and y value. Doesn't matter what we call y. If we call it f, or if we call it k, or if we call an apple, it's still between those two axes. So I'm looking for the value of y, this value of y, when x is what? At the same point, the x is 2. So we are taking our derivative, and we are saying when x is 2. So we are replacing x with 2. And we put that in the calculator, we press equal, and we get that that value of derivative is 4. And therefore, that is the value of the slope. So that is kind of a little bit of knowledge that we need here in order to answer that question.